Welcome, athletes, to part 3 of our antiderivative study here. And in this case, we're talking about initial value problems. So we talked about the fact that when we take an antiderivative or an indefinite integral, we have to account for the constant that may or may not have been there in the original function, right? In the antiderivative, and so now we're going to find a way to actually calculate that constant, right? And we do need to know some type of information, right? Like, for example, if we have a function here like dy dx equals 6x squared. So if we have some function where we know, and we'll call that the f of x. So let's say f of x is 6x squared, right? Then if we take the antiderivative, we find capital F of x, then that would be, we would add 1 to the exponent, right? So that would be x cubed, and then we would divide by what we just got there, 3. And so that would be 2x cubed, right? So we get 2x cubed here. But then we don't know exactly what that constant was or could have been in order to get this final result, right? Or in order to get this derivative, I should say. And so remember, like here the graph, we can see this could have been a lot of things. It could have been 2x minus 3, 2x plus 3, 2x cubed plus 3. I mean, excuse me, 2x cubed minus 3, 2x cubed plus 0, right? 2x cubed plus 3 or 2x cubed plus 6. So it could have been any of those and more, right? Those are just a few possibilities, but there's an infinite amount of possibilities for the value of c. And so we don't know exactly what that is. So we're going to be giving some kind of initial condition. So here it says y of 1 equals 5. So basically they're giving us this input and they're saying, hey, this, I'll just use capital F since we've been using it here, but they're giving us these initial conditions to say, hey, when x was 1, the output was 5. And so what we can do with that is we can plug in 5 for this, and we can plug in 1 for x, and we can solve for c. So that's what we'll do, is we'll say, okay, well, 5 equals 2 times 1 cubed plus c, and we'll be able to actually solve for c. And so 1 cubed is 1, so that's just going to cancel out to 1. So 2 times 1 is 2. So I'm going to subtract 2 from both sides. And we will get these to cancel out. And so c equals 3. Okay? And so now we can rewrite our function as capital F of x equals 2x cubed plus 3. So now c is 3. So we can put that in there for c. And this is our final, our specific function, right? Not just the general form, but our specific function. We can see that this is the one that works, right? And here's the point, like this initial condition where when x is 1, y is 5, right? That satisfies this line, right? Not these other lines, okay? All right. And so that's what we'll do, is we will be given an initial condition, and we'll use that to find our constant, our unknown constant in our antiderivative or integral. Okay.